Howdy, this is group number 12, and we had Bayes rule application problem number 4. So we chose problem number 4, and it was about a popular online game that uses 3 servers, Stardust, Ochre, and Task. And when new users log in for the first time, there's a chance that the game will crash due to a critical error. The probabilities of each server crashing are as follows. Stardust has a 10% chance of crashing, Ochre has a 3% chance, and Task has a 20% chance. Login attempts are distributed as follows. 30% of attempts go to Stardust, 50% to Ochre, and 20% to Task. After you create an account and log in, the game crashes. We were asked to find the probability that your login was handled by Stardust, and as well as the probability it was handled by Ochre. So a conditional probability is a probability of an event occurring given that another event has already occurred. It quantifies the likelihood of an event happening under the condition of the presence of another event. So the formula for conditional probability is P B slash A is equal to P times A and B divided by PA. And an outside example of this is that if the sky is cloudy, there's a moderate to high percent chance of rain, but it's not guaranteed because not all clouds will produce rain.
So what is Bayes' rule, you may ask? Well, the definition is a mathematical formula used to solve problems of conditional probability where the goal is to determine the likelihood of an event given the occurrence of another event B. And it is written like it is at the top right corner, which is the probability of H given E is equal to the probability of H multiplied by the probability of E given H, all divided by the probability of H multiplied by the probability of E given H plus the probability of not H multiplied by the probability of E given not H. And Bayes' rule can be applied in situations such as uncertainty, decision making, and inference. And it allows for us to revise our current beliefs, in this case, probability, in light of new evidence. And examples that Bayes' rule could be beneficial to apply would be medical diagnosis, such as testing for certain diseases, and things like weather forecasting. Bayes' rule takes our prior knowledge and adds new evidence to build on and create a more accurate probability. It builds off the conditional probability formula, which is shown under Bayes' rule, which reads the probability of A given B is equal to the probability of A and B over the probability of B. Bayes' rule builds off of this by giving 2 events versus just 1 event. And it is an essential tool that allows for greater accuracy in probabilistic reasoning as new evidence arises. So essentially, Bayes' rule answers the question, do the premises make the conclusion more or less likely, and how much more or less likely does it make it?
So looking at Bayes' rule and kind of breaking it down, there are really 4 different types of probabilities that you can find. The first is the probability of the evidence, the second being the probability of the hypothesis, and then the third one is the probability of the evidence given the hypothesis, and then the last would be the probability of the hypothesis given the evidence. So again, how that looks in the formula that was stated prior, and then is listed again here is just the probability of the hypothesis conditional to the evidence and what that looks like.
All right, now that Sarah has talked about the different types of probabilities, right? The probability of evidence, regardless of the hypothesis, probability of the hypothesis before considering the evidence, and so on and so forth, that plays directly into calculating the problem that we got for our assignment in the video. So calculation 1, which is going to be the probability your login attempt was handled by Stardust, right? So now understanding Bayes' rule, right? So it's like prior knowledge, new evidence, which turns into an updated belief. All right, so we have on this left side right here, the probability of crashing, which is the conditional, right? So the probability, if Stardust is the server handling the login, there is a 10% chance the game will crash. Whereas for Okra, right, if Okra is the server handling the login, there is a 3% chance the game will crash. With Task, it is a 20%, and then there is a 40% no crash. Moving on to login attempts or prior. So essentially what this means is prior to choosing a server, a certain percentage of the login attempts are handled by a certain amount of servers, right? So for instance, for P, parentheses Stardust, or the probability of Stardust, 30% of all login attempts are handled by Stardust. 50% of all login attempts are handled by Okra, and 20% of all login attempts are handled by Task. All right. Now getting into the long form or the general form down here. This is the equation down here. Again, we're just going to in place the numbers into the correct spots, right? So if we have, for instance, the probability that Stardust crashes, right? We're going to input that into the problem below, and that's what you are going to see on this next slide here. So here we go. So again, take a look at this slide. We're going to bounce back. This is all I'm doing is I'm taking the numbers from the left and the right column, and I'm plugging them in to the long or general form below, right? And that's what we get right here. So again, we're going through the numerator, then the denominator. And as you can see, I just plugged and played. So right now, we're trying to find the probability that Stardust handled your login, given that the game crashed, right? So here we go. We're just substituting the value. So right here, the actual equation with substituted values, right? So is right here. So the probability that Stardust handled your login and it crashed, right? So it's going to be 0.03 over 0.085, which in turn equals 0.3529. Or in simple terms, the probability that Stardust handled your login, given that the game crashed, is going to be 35.29%. Now, staying with me, it is the same thing that we're doing, but for Okra now. So we have just two different calculations. So this is the probability that your login attempt was handled by Okra. So on this left side, the conditional, right? And then right side, we've got the priors, right, or the login attempts. So same thing that we're doing. Right? So if we come back, it's if blank is the server handling the login, there's a blank chance the game will crash. So if Stardust handles the login, there will be a 10% chance the game will crash, and so on and so forth as we move down the column. Same thing with this. If we bounce back, blank percent of all login attempts are handled by. So in total, blank percent of all login attempts are handled by, and it's the same numbers. As you can see, I'm not changing anything. It's the same numbers. But we're just looking for a different variable. Now we're looking for we're looking for the probability that Okra handled your login, given that the game is crashed, right? So bouncing back, this is just the different long form or general form. However, solving for the probability that we used Okra, the server crashed. Coming here, right? Same thing, substituting the values. And here you get it's 0.015 over 0.085. And if you're confused, we can bounce back, right? So all we're doing for the numerator, right, just as we did for the numerator in the first equation for Stardust, is we're solving for the probability of crash with Okra, and then as well as multiplying it with the percentage of login attempts that it is without concerning crash rates. So here we go. So the probability that Okra handled your login given the game or server crashed, is 17.65%. So in conclusion, there you go. The probability your login attempt was used by Stardust, 35.3%. Probability your login was used by Okra, 17.6%. And I would like to say the disparity here is the probability that certain server handled your login given that the game has crashed. Thank you so much for listening. Again, in the general realm of Bayes' rule, what's a really cool thing about this theory, right, is you get to take prior knowledge and then you get to take ever-evolving new evidence and turn it into a new updated belief or new equation, which is what Bayes' rule is so cool. And you get to really use a lot of these theories when it comes to logic. All you're doing is you're breaking down simple sentences and turning it into mathematical equations, right? So we're taking these simple questions, right? What is the probability that Okra handled your login? And we're just turning it into P parentheses Okra parentheses 0.5. Simple terms, 50%. Math terms, 0.5. Thank you so much for listening to our presentation. And if you have questions, please leave them in the comments below. Bye-bye.